Welcome back to the Cisco Netacad CCNA Switching, Routing and Wireless Essentials lecture series. If you haven't seen my previous lectures, I will leave a link in the description for the playlist. I would also recommend that you watch the Introduction to Networks lecture series before you move forward with this course. Today, I will cover module number 15, IP Static Routing. In this lecture, the primary objective is to learn how we can configure IPv4 and IPv6 static routes. Hence, this module is also a little bit lab heavy. However, I will not go through the live lab demonstration during this lecture. I will post them on a separate video. I will cover the topics related to IP static routing. That includes the static routes, how we can configure IP static routes on IPv4 and IPv6, the configuration of default static routes, the configuration of floating static routes, and how we can do the configuration of static host routes. Static routes. So what are the types of static routes? Static routes are commonly implemented on a network. This is true even when there is a dynamic routing configured. Static routes can be configured for IPv4 and IPv6, and both protocols support the following static routes: standard static route, default static route, floating static route, and summary static route. Static routes are configured using the IP route command and IPv6 route command in global configurations. Next hop options. When configuring a static route, the next hop can be identified by an IP address, exit interface, or both. How the destination is specified creates one of the three following types of static routes. So based on how you configure the destination, it can create one of the following three types. Next hop route, which is only the next hop IP address is specified. Directly connected static route, which only the router exit interface that is specified. Fully specified static route, that is the next hop IP address and the exit interface are both specified. So these are the three types of next hop options: next hop route, directly connected static route, and fully specified static route. IPv4 static route command. So on your Cisco lab exams and lab modules, you will be using these commands to create these static routes. So in IPv4 static routes, that can be configured using the IP route command with available options. So in here we have the IP route command, and we have the available option of entering the network address, subnet mask. So the network address going to be the IP address and the subnet mask associated with that, and the distance. So the either IP address or exit INTF or the IP address and the exit INTF parameters must be configured in order for this command to be completed. So when you're working on your labs and you're not sure what needed to be entered, remember the question mark command that will give you some helpful hints in Cisco IOS. So if you don't remember these options, and you don't have that written on your lab documents or your lab manuals, you can always use that question mark to figure this thing out. IPv6 static route command includes the similar command, but now we just add the 6 here. So IP, remember on the previous one we have IP route, and in here IPv6 route. So we just add V and 6, so version 6. So IPv6 route, and then you can enter the available options such as IPv6 prefix and the prefix length. So most parameters are identical to the IPv4 version of the command, except slightly different input here with the IPv6 as opposed to IP route. and the options available, because this is IPv6 configuration now we are looking at. dual stack topology. The figure on the bottom shows a dual stack network topology. Currently, no static routes are configured for either IPv4 or IPv6. So we have a dual stack topology. What that basically means is you have a section here with the routers dividing the broadcast domain here, and we have another one dividing up here, and then we have a topology with no static routes currently configured. So remember this dual stack topology for your next few slides, because that's what we will be using for showing you the configuration options. Again, I will do these on a live lab demonstration on separate videos and post to my YouTube channel. So I'm not going to repeat that again and again because it's probably going to be annoying for you. I keep saying that on every single lecture that I go through. But remember, this is a little bit of lab heavy lecture. So I'm just covering the theory part. So once you understand the theory part, it will be much easier for you to complete your labs, right? So that's why. So remember this topology. You can take a screenshot if you like right now. So the IPv4 starting routing table. Each router has entries only for directly connected networks and associated local addresses. R1 can ping R2 but cannot ping the R3 in the LAN. So if you go back here, remember the R1 can ping R2 but it cannot ping R3 because it has to go through this router which is breaking down that domain, right? Same goes the other way around. R3 can ping R2 but not R1. So R1 can ping R2 but cannot ping the R3 LAN. So if you enter the command on R1, show IP route with piping into begin with gateway. So we are filtering just the gateway information and it will show up this data right here. And if you ping the 172.16.2.2, it will be 100% successful. But if you ping the R3 router, which is the 192.168.2.1, remember on the topology, R3 router is sitting right here, right? In that case, what's going to happen, this 192.168.2.1 going to fail because it can't see the router behind the router. It can't go through that. So now if we look at the IPv6 routing tables and do the same thing, you can use the command show IPv6 route piping into begin with C in this case because we are looking at the IPv6 tables. And if you don't remember what the C's and L's stand for, you can check my previous lecture, just the immediate previous lecture to this one, and that will explain what these are and how these tables are done. So we're going to run show IPv6 route. We are piping begin with C. We are filtering C, and it's going to show all the directly connected networks. And if you ping, if you do the same thing, the R2 from the R1, the ping will be successful on IPv6 as well, just like the IPv4. But the ping for the IPv6 address for the router 3 will not go through because it will fail as a result of being behind another router. So if you remember, it's the same thing with the pings for the IPv4. The ping towards the R3 from the R1 failed, and the same thing here as well. Ping towards the R3 from the R1 has failed. So to solve this issue, one way of we can mitigate this is to use static routes, right? So now we're going to learn how we can configure IP static routes. IPv4 next hop static route. In a next hop static route, only the next hop IP address is configured into your router. So the exit interface is derived from the next hop. In this example, the 3 next hop IPv4 static routes are configured on R1 using the IP address of the next hop on R2. So as you can see in the R1 configuration, we're going to enter IP route and we're going to enter the IP address of the next hop and the subnet mask and the address. So it's going to have the exit interface showing this one. So this is the next hop exit interface actually. So and we're gonna enter the next one and next one. So you can enter like multiple static route. Each time what you need to do is use the same command and enter the proper configurations associated with those static routes. So in this case we are using 172.16.1.0 and static route here, and this 192.168.1.0 static route here, and then 192.168.2.0 static route here. So we have 3 entries. Then if you enter show IP route and if you filter begin with gateway in here, so we are piping gateway, you will see those static route entries that you have just entered up here. So these are the ones that's showing up here. So that confirm that you have created the next hop static route. IPv6 next hop static route. So the commands to configure R1 with the IPv6 static routes to the 3 remote networks are shown here. It is kind of similar to that of the IPv4, but it has a little bit of more information that you need to enter. So the first thing you need to enter, the little bit of key information in IPv6 is you need to enter IPv6 unicast-routing. If you remember from my previous lecture, this command ensures that your router is ready to exchange IPv6 information, right? That's how you make sure that IPv6 is up and running. So you can enter IPv6 unicast-routing. Then to configure those IPv6 next hop static route, you're going to enter IPv6 route, similar to IPv4 route. In this case, instead of IP route, it's going to be IPv6 route. And then you're going to enter the information configuration information up here. So you have, in here we have 3 entries. And if you run the command show IPv6 route, and you can see those static routes showing up here, and they are labeled with S conveniently so that it's easy for you to identify. And whatever you have entered in here with respect to those static routes, it is going to be statically assigned by this router. IPv4 directly connected static route. So when configuring a static route, another option is to use the exit interface to specify the next hop address. So remember, in the previous one, if you go back, we are using the IP address to configure the the IP, the information here, right? So the next hop is defined by the IP address and information. But another way to do it is the exit interface to specify the next hop address. So right here, you can see the change. Right now we are using the exit interface. So the 3 directly connected IPv4 static routes are configured on R1 using exit interface this time. So using a next hop address is generally recommended as opposed to using a exit interface. Directly connected static routes should only be used with point-to-point serial interfaces. So the only time typically directly connected static route are used when we have the point-to-point serial interfaces. So if you want to do that, you're going to do IP route and you're going to give the IP address and subnet mask. And right now we're just going to give the exit interface, in this case S0100. And remember from the previous time, we are giving the IP address, which is 172.16.2.2. That's exit interface IP address for these static routes. But in here, what we are doing is we are giving the exit interface for these static routes instead of the IP address. So now if you enter show IP route and if you filter or pipe the begin gateway, you're going to end up with 192.168.2.0/24 directly connected information right here, which is entered up here by you, right? So that's what it is showing. IPv6 directly connected static route. In this example, 3 directly connected IPv6 static routes are configured on R1 using the exit interface. So again, if you go back to our previous IPv6 slide where we have used the exit IP address, this time we're going to use the actual interface, in this case S010. So it's very similar to that of the IPv4 using exit interface. So you can see those similarities between the IPv4 and the IPv6 is just now using exit interface. Using a next hop IP address is generally recommended, and remember, directly connected static route should only be used with point-to-point serial interfaces. So that's a key feature, key important concept that you should understand for both IPv6 static routes as well as the IPv4 static route. So directly connected static route should only be used with point-to-point serial interfaces. IPv4 fully specified static route. In a fully specified static route, both the exit interface and the next hop IP address are specified. This form of static route is used when the exit interface is a multi-access interface and is necessary to explicitly identify the next hop. The next hop must be directly connected to the specified exit interface. Using an exit interface is optional. However, it is necessary to use the next hop address. So remember that. Using an exit interface is optional in this case, but it is necessary to use the next hop IP address for this particular configuration. So in this type, so it is recommended that when the exit interface is an Ethernet network, that the static route includes a next hop address. You can also use a fully specified static route that includes both the exit interface as well as the next hop address. So you can also use a fully specified static route where you have both the exit interface as well as the next hop address. And on the right hand side, that's what it's actually showing. So in here we have IP route command for IPv4, as you know, because this is IPv4 command, and you have the routes defined here and the subnet mask, and you have the exit interface and the IP address associated with it. Now we are explicitly defined, fully specifying the static route from for this router. And if you run the show IP route pipe filter begin gateway, you can see those entries with S again here with that all that data that you have entered up here. IPv6 fully specified static route. So in a fully specified static route, both the exit interface and the next hop IPv6 address are specified in this case, and there is a situation in IPv6 when a fully specified static route must be used. Unlike the IPv4, it is an optional use. If the IPv6 static route uses an IPv6 link local address as the next hop address, use a fully specified static route. So one place that you must use the fully specified static route is that if the IPv6 static route uses an IPv6 link local address as the next hop address, then you have to use the static route. The figure shows an example of a fully specified IPv6 static route using IPv6 link local address as the next hop address. So in here on the bottom of the screen, you have two routers, R1 and R2, and it is connected via IPv6 link local addresses. And in this case, we're going to use a fully specified IPv6 static route by using the IPv6 route command with this fully specified configuration, and then it would configure on your R1 router as such. The reason a fully specified static route must be used is because IPv6 link local addresses are not contained in the IPv6 routing table. Link local addresses are only unique on a given link or network. The next hop link local address may be a valid address on multiple networks connected to the router. Therefore, it is necessary that the exit interface be included. So that's a key piece of information you should remember when you are configuring IPv6 networks. The following example shows the IPv6 routing table entry for this route. Notice that both next hop link local address and the exit interface are included. So if you look at this, show IPv6 route static, and we are filtering that particular IP address, their network, and then you can see that both the next hop and the link local address and the exit interface is specifically explicitly defined. And why we do it is, I just went over why it is important, because the link local addresses are only unique on a given link or network, and the next hop local address may be a valid address on a multiple connected networks, and that's why you must have that XCD interface included when you are configuring this. So these are key pieces of information you need to remember for your lab exams, specifically lab exams, but also some of the CCNA and CCNP multiple choice lecture exams as well. As you go through the labs, you will get to know these concepts like back of your hand. For this particular lecture that I'm doing right now, what you need to understand is what are the differences between different types of static routing and how you can configure it. As you go through the labs, you will get to know in depth, like back of your hand. So right, so remember that this lecture is a little bit of lab heavy, so remember to keep that in your mind. So how do you verify your static route? Along with the show IP route, show IPv6 route, you can also use ping and trace route and other useful commands to verify static routes, including show IP route static, show IP route, then you can enter the network address, and show running -config, and then you can select or pipe the IP route part of it, and you can replace IP with IPv6 for the IPv6 versions of the command. So in here right now you can put show IPv6 route static, that will show you the IPv6 data, show IPv6 route, then enter the IPv6 information, then it will give you the IPv6 data. So that's what it meant by here, replace IP with IPv6. Configure IP default static routes. Default static routes. A default route is a static route that matches all packets. A single default route represents any network that is not in the routing table. Routers commonly use default routes that are either configured locally or learned from another router. The default route is used as the gateway of last resort. So one of the key things here that I just went over, a lot of students and even I, when I was studying for this, sometimes forget the fact that the default routes can either be configured or can be learned from another router. So default route doesn't necessarily have to be configured by a network administrator. It can be learned from another router. So remember that. That's a piece of information sometimes some students forget. And default route is used as the gateway of last resort. So you may hear me and many other instructors and presenters will use gateway of last resort or default route interchangeably, because default route is also used as the gateway of last resort, but in default, they are not really synonyms of each other, but they are pretty closely related, like the default route and the gateway of last resort. So most people would interchangeably use it, even though it's probably not the best idea. So remember that. So if you're taking a class at the university and you are going through your CCNA, CCNP lectures, you may hear your instructors and lab instructors may use the term default route and the gateway of last resort as a synonyms of each other, even though it's not really so. Default static routes are commonly used when connecting an edge router to a service provider network or a stub router, which is a router with only one upstream neighbor router. The figure on the right hand side shows a typical default static route scenario. So in here, we have a stub router right here, and it is connected to a network, and you have the stub network over here, and the default route will be configured. The default static route will be used on the edge router so that it would connect to the service provider for the network, right? So that's what mostly common use case. You should know this information for your lecture exams. They do show up. IPv4 default static routes. The command syntax for the IPv4 default static route is similar to any other IPv4 static route, except that the network address is set all to 0 and subnet mask is set all to 0. So all the octets are 0, 0, 0, 0, 0. So you have 4 zeros on both of them. The 0.0.0.0 space 0.0.0.0 in the route will match any network address, because the IP and the subnet mask are both set. Network and the subnet mask is set both to 0, 0, zeros. Note, an IPv4 default static route is commonly referred to as the quad 0 route. It's pretty obvious, right? Because it's 4 zeros. So IPv4 static route is commonly referred to as a quad 0 route. That's another term that you may hear in the field as well as from your instructors. The basic command syntax for the IPv4 default static route is similar to this. Actually, this is exactly that. So if you have a Cisco router, you will be entering IP route and you're going to enter 00000000. So now you have a default static route, and then you can enter the IP address associated with that and the exit interface. So you need to complete this command with this information as well. So either you're going to enter the IP address or the exit interface. So it will be like IP route 0.0.0.0 space 0.0.0.0, and you're going to enter either the IP address or the exit interface and click enter and on your CLI or your command line, and then that will get you the IP default static route enter into your Cisco router. For IPv6 default static route, the command syntax is for that is similar to any other IPv6 static route, except for the IPv6 prefix and prefix length is now set to ::/0, which matches all routes. Remember, in here we have make sure that it matches all route by using quad zeros because it's IPv4, but for IPv6, because we are using hexadecimal and stuff like that, we're going to use the ::/0 that will match all routes. So the basic command syntax for the IPv6 default static route for Cisco devices is going to be IPv6. So IPv6 route. So it's similar to IPv4 version, which is IP route. In here, we're going to use IPv6 route, and we're going to use ::/0, and we're going to give either the IP address or the exit interface to specify here, and press enter, and that will get you the IPv6 default route configured on your Cisco router. Configure a default static route. The example shows an IPv4 static route configured on R1. With the configuration shown in the example, any packets not matching more specific route entries are forwarded to R2 at the 172.16.2.2 IP address. So if this router receives any packets that is not matching any other specified route, it will be forwarding automatically to the 172.16.2.2, which is associated with R2 by entering IP route quad 0 172.16.2.2. That will take care of that default route. So that's how you configure it. And basically, again, every single time a packet is received and it doesn't find where it needs to go, it will forward it to this address. An IPv6 static route is configured in similar fashion. With this configuration, any packets not matching more specific IPv6 route entries are now forwarded to R2 using the IP address 2001:db8:acad:2:2, right? Why? Because we have entered the IPv6 route ::/0, which is the default static route configuration, and we specify the IP address for that default route, which is 2001:db8:acad:2:2. And when you press enter, that will configure the IPv6 default route. So how do you verify a default static route? The show IP route static command output from R1 display the contents of the static route in the routing table. So right here. Note the asterisk, which is this symbol, next to the route with the code S, which is just S, like it's S symbol. So the asterisk indicate that this static route is a candidate for the default route, which is why it is selected as the default, selected as the gateway of last resort. So you can see right here, we have a S and that star symbol, right? So some people call it star symbol, some people call it asterisk. I call it star, but it's asterisk. So this S asterisk basically means that it is indicating that is a static route that is a candidate for the default route, which is why it is selected as the gateway of last resort. Notice that the static default route configuration uses the /0 mask for IPv4 routes. Remember that the IPv4 subnet mask in a routing table determines how many bits must match between the destination IP address of the packet and the route in the routing table. The A/0 mask indicates that none of the bits are required to match. As long as more specific match does not exist, the default static route matches all the packets. So that's what it is. As long as a more specific match does not exist, the default static route matches all the packets, because that's the way it's set up, code 0/0 and this, and so that's why it works that way. So in this example on the bottom of the screen, now we have a IPv6 example. So we are using the show IPv6 route static command right here in the R1, and notice that the default route configuration uses the ::/0. You can see that right here, :/0 prefix. And remember that the IPv6 prefix length in a routing table determines how many bits must be matched between the destination IP address of the packet and the route in the routing table. A ::/0, a ::/0 prefix, indicates that none of the bits are required to match. So as long as a more specific match does not exist, the default static route matches all the packets, because we have the default static route set right here with the associated IP address. Configure floating static routes. Floating static routes. Another type of static route is a floating static route. Floating static routes are static routes that are used to provide a backup path to a primary static or dynamic route. So if during an exam, whether it's a lab exam, your instructor asking you questions verbally, or during a lecture exam, if somebody asks what is a floating static route, that's the answer. Floating static routes are static routes that are used to provide a backup path to a primary static or dynamic route. The floating static route is only used when the primary route is not available. So remember that the floating static route is only be used when the primary route is not available. To accomplish this, the floating static route is configured with higher administrative distance than the primary route. The administrative distance represents the trustworthiness of a route. If multiple paths to the destination exist, the router will choose the path with the lowest administrative distance. So if there are, remember, this is from our previous lectures, if multiple paths exist, the router will always choose the path with the lowest AD, right? So if you don't remember those lecture concepts that I went over on my previous lecture, please go back and watch that video, because this is kind of a build on top of that. By default, static routes have an administrative distance of 1, making them preferable to routes learned from dynamic routing protocols. The administrative distance of a static route can be increased to make the route less desirable than that of the another static route or route learned through dynamic routing protocol. So remember that you can manually increase or decrease either way to make the router less desirable than another static route, depending on your configuration. So in this way, the static route, which is floats, in this way the static route floats and is not used when the route with the better administrative distance is active. So that is the whole concept behind the floating static routes. This is a very important concept also you need to remember for your exams and quizzes, so make sure you go over this before your exam. Configure IPv4 and IPv6 floating static routes. So the commands to configure default and floating IP routes are shown here. So floating IP default routes in here as well. So you can see the configuration that you need to enter for your Cisco router, and these are the entries that you need to make. And you can use a show IP route and show IPv6 route output to verify the default route to R2 are installed in the routing table. And note that the IPv4 floating static route to R3 is not present in the routing table. So you can see that right here. So it shows show IP route static. We are filtering out the begin with gateway, and that is actually showing right here, the gateway of last resort shown right here, and then show IPv6 static begin with S, and it shows right here. So these are the two things that show. So how do you test the floating static routes? So what would happen if R2 fail? So that's how we basically can do the testing for the one way of testing these floating static routes. So you need to think about what would happen if in this particular network diagram the R2 to fail, right? So to simulate this, we can shut down the R2 by shutting down both serial interfaces. So you can shut down serial interfaces here. So the R1 automatically generates syslog message for the link going down. So you will see the link going down as a syslog message on the CLI. If you look at the R1's routing table, would show the secondary route being used now. So as a result of that link going down, now the secondary route will be in use. So that's the one way of testing that floating static route. Again, if you just go through this lecture and look at these slides and listen to me, you're probably gonna get confused a little bit. So I will go through the labs and I will demonstrate this, and testing cases, and I will build this topology on Cisco Packet Tracer example, and I'll post to my YouTube channel so you'll have a better understanding of what I just went over. Configure static host routes. Host routes. A host route is an IPv4 address with a 32-bit mask or an IPv6 address with a 182-bit mask. The following shows the 3 ways a host route can be added to the routing table. They are automatically, those 3 options include automatically installed when an IP address is configured on the router, configured as a static host route, or host route automatically obtained through another method, which we will discuss later courses, but not in this course because those involve advanced routing concepts. That is the next lecture series that I'll be posting. So let's look at the automatically installed host routes. Cisco IOS automatically installs a host route, also known as a local host route, when an interface address is configured on the router. So if the interface address is configured on the router, it will be considered as like a local host route. A host route allows for a more efficient process for packets that are directed to the router itself rather than for packets forwarding. This is in addition to the connected route designated with a C in the routing table for the network address of that interface. The local routes are marked with L in the output of the routing table. So the C will have, designate a C with the connected and the L with the local route on the routing table. Again, when I go through the lab videos, I will show you on a live demo. Static host routes. A host route can be manually configured static route to direct traffic to a specific destination device, such as the server shown in the figure. So right here we have a server. So servers, we typically use static addresses and static routes for servers because they don't usually change much, and we need that constant connection. So the static route uses a destination IP address and a 255.255.255, which is 255.255.255.255, which is a 4 255s that will give you /32 mask for the IPv4 host host routes, and a /128 prefix length for the IPv6 host routes. So in this example, so that would be what we are going to configure as the static host route. The example shows an IPv4 and IPv6 static host route configuration on branch router to access the server. So we remember we have a branch router right here. So it's trying to access the server. So we need to configure the static routes on that branch configuration, right? So we have entered the IP route, which is the IPv4 command, and we have that static route configuration information. Those options, again, I will go through them in a real lab demonstration. For now, just know this is how you do it. So we have the IPv6 version, which is IPv6 route, and the static route configuration, and these two commands will make sure that that get configured properly. And again, remember, you need to run show running config, startup config, otherwise if you reboot these routers, you're going to lose everything. I will go through them on lab demos and post to my YouTube channel later. So finally, verify static host routes. A review of both IPv4 and IPv6 route tables verify that the routes are active, and how you do it, you just simply run the show IP route and begin with gateway, and you see those static routes showing up on both show IPv6 route as well as show IP route, which is IPv4 version, and IPv6, which both of them shown with this S with those static routes configured right here. Configure IPv6 static host route with the link local next hop. So for IPv6 static routes, the next hop address can be the link local address of the adjacent router. However, you must specify an interface type and an interface number when using a link local address as the next hop, as shown in this example. So right here in this example. First, the original IPv6 static host route is removed. Then fully specified route configured with IPv6 address of the server and the IPv6 link local address of the ISP. So first what you need to do is, because when if you go back to our diagram, when this is first set up, it's going to automatically get some of the IPv6 information. So the first thing we need to do is to remove that original static host route. So by typing no at the front with the IPv6 route, and then you're going to enter that route information, and then you're going to enter, the next thing we're going to do is fully specify that configured IPv6 of the server with IPv6 link local address of that ISP router. So that's what we are doing right here. And then it will show up under the command show IPv6 route, and we can pipe it or filter it, begin with : and you can see that showing up with this S, and right here is showing up that information that you just configured. So that would bring us to the end of this lecture. And now I will go over what we have learned and some of the packet tracer files available to you for the comprehensive understanding of the topics that we have covered. So there is a packet tracer file called configure IPv4 and IPv6 static and default routes. If you have access to this packet tracer file through your Cisco NetAcad or through your academic institution, please go ahead, download and do them. If you do not have access to this packet tracer file, I will try to either obtain a copy of it or create one and post to my sanuja.com website later sometime. Same goes for the lab. It is called the configure IPv4, IPv6 static route and default routes. If you have a copy, go ahead and do them. If you do not, I will try to obtain a copy and post to my website sanuja.com so that you can get some hands-on experience. So here's a summary of the things that we have covered. So I'm going to cover that on next 2 slides. We learned that static routes can be configured for IPv4 and IPv6. Both protocols support the following types of static routes: standard static route, default static route, floating static route, and summary static route. And we went over all of them. When configuring a static route, the next hop can be identified by an IP address, exit interface, or both. How the destination is specified creates one of the 3 following types of static routes. They include next hop, directly connected, and fully specified. IPv4 static routes are configured using the following global configuration command. That is IP route network -address subnet -mask. So basically you have, so I worded it in a weird way. Basically you're going to type IP route, then you're going to enter the network address, and you're going to enter the subnet mask, and then the associated data if you want to. And then IPv6 static routes are configured using the following global configuration command, which is IPv6 route, and then we're going to enter the IPv6 prefix and the prefix length. So that's how you do it with IPv6. We learn in a next hop static route, only the next hop IP address is specified. The exit interface is derived from the next hop. When configuring a static route, another option is to use the exit interface to specify the next hop address. We learn about the directly connected static route should only be used with point-to-point serial interfaces. In a fully specified static route, both the exit interface and the next hop IP address are specified. This form of static route is used when the exit interface is a multi-access interface and it is necessary to explicitly identify the next hop. The next hop must be directly connected to the specified exit interface. We also learn in a fully specified IPv6 static route, both the exit interface and the next hop IPv6 address are specified. We also learn a default route is a static route that matches all packets. So in other words, if the packets have nowhere to go, it will use the default route because it matches all packets. So the default static routes are commonly used when connecting edge router to a service provider network and a stub router. The command syntax for the IPv4 default static route is similar to that of the IPv4 static route, except that the network address will be set to COT zeros and the subnet mask will be set to COT 0 as well. The command for the command syntax for the IPv6 default static route is also similar to that of the other IPv6 static route, except at this time we're going to use the ::/0 for the prefix, and then it matches all routes. Floating static routes are static routes that are used to provide backup path to a primary static or dynamic route in the event of a link failure. So if somebody asks you what is the purpose of the floating static route, that is the purpose of the floating static route. The floating static route is configured with a higher administrative distance than the primary route. By default, the static routes have an administrative distance of 1, making them preferable to routes learned from the dynamic routing protocols, which we are not covering in depth in this lecture series, but we will cover dynamic routing protocols in depth in our next lecture series. IP floating static routes are configured by using the distance argument to specify an administrative distance. A host route is an IPv4 address with a 32-bit mask for an IPv6 address with a 128-bit mask. We also learned there are 3 ways a host route can be added to the routing table, which are automatically installed when an IP address is configured on the router, or configured as a static host route, or automatically obtained through other methods which are not covered in this lecture series. Cisco IOS automatically installs a host route, also known as local host route, when an interface address is configured on the router. We learn a host route can be manually configured static route to direct traffic to a specific destination device. We also learn for IPv6 static routes, the next hop address can be the link local address of the adjacent router. However, you must specify an interface type and an interface number when using link local address as the next hop. To do this, the original IPv6 static host route is removed when a fully specified route is configured with the IPv6 address of the server and IPv6 link local address of the ISP router. So remember that. To do this, what we do is the original IP static route going to be removed with the no command at the front and the original static information, and then we're going to specify the fully configured IPv6 address with the server and the IPv6 link local address of the ISP router. If you like these type of lectures, please thumbs up this video and subscribe to my channel. If you have any questions with respect to any of the topics that we have covered, please do not hesitate to contact me either through my sanujja.com website or by leaving a comment on this YouTube video. Until next time, good luck with your exams and have a nice day.